Since 1972, UNESCO has been making a contribution to peace building and sustainable development in its member states, thanks to its unique remit in earth sciences. What is a UNESCO Global Geopark? They are the most recent UNESCO site designations for protecting geological sites of international significance. The 195 members of UNESCO ratified the creation of a new UNESCO label, the UNESCO Global Geoparks, on the 17th of November 2015. The decision was taken by member states at UNESCO's General Conference, the governing body of the organisation. This expressed governmental recognition of the importance of managing outstanding geological sites and landscapes in a holistic manner. As of 2021, there are 161 UNESCO Global Geoparks in 44 countries. So how do we distinguish UNESCO Global Geoparks from UNESCO World Heritage Sites and UNESCO Biosphere Reserves, which are the other two prestigious labels of UNESCO site designations? The UNESCO Global Geoparks are sites and landscapes of international geological significance as independently verified by scientific professionals. It's important that they're identified as single, unified geographical areas. They cannot be made up of separate, smaller areas within a region. They will typically have a multitude of sites of specific interest and must be contained within the designated area. Within the geopark, there will be links between the area's geological heritage and its natural, cultural, and intangible heritage. So in a region, local people will celebrate their unique geological heritage and combine those features with their rich cultural heritage, their landscape, wildlife, food, people, storytelling. Each one combined is used to promote the region's earth history. So what are the advantages of UNESCO Global Geoparks for UNESCO member states? A UNESCO Global Geopark uses its geological heritage in connection with all other aspects of the area's natural and cultural heritage to enhance awareness and understanding of key issues facing society, such as using our planet's resources sustainably, reducing the impact of natural disasters, mitigating the effects of climate change. The key to solving these issues is that the UNESCO Global Geoparks should use that heritage in connection with all other aspects of that area's natural and cultural heritage to promote awareness of key issues facing society in the context of the dynamic planet we all live in, including, but not limited to, increasing knowledge and understanding of geoprocesses, geohazards, climate change, the need for the sustainable use of Earth's natural resources, the evolution of life, and the empowerment of Indigenous peoples. They'll be managed with a holistic concept of protection, education, and sustainable development. The creation of innovative local enterprises, new jobs, and high-quality training courses is stimulated as new sources of revenue are generated through geotourism, whilst the geological resources of the area are protected. By raising awareness of the importance of the area's geological heritage in history and society today, UNESCO Global Geoparks give local people a sense of pride in their region and strengthen their identification with the area. If you would like to become part of UNESCO's Global Geoparks family, please contact us. Men will be taught that beneath and behind all the outward beauty of our lowlands, our uplands and our highlands, there lies an inner history which, when revealed, will give beauty a fuller significance and an added charm. Archibald Geeky, Landscape and Literature, 1905. Our planet is such a special place, enlivened by an incredible ecological richness of fauna and flora. But the accelerating loss of natural habitat and species mean that biodiversity is on everyone's lips. And yet, underpinning biodiversity is its hidden silent partner, geodiversity. The basis of every ecosystem are the non-living elements of nature: rocks, minerals and soils, and landforms and topography, mountains, gorges, rivers and lakes. This geodiversity has its own intrinsic value, worthy of protection. And it has an essential role for the human planet. It provides the building stones for our towns and cities. And it provides the material for our energy resources, including renewable energy. So as well as underpinning biodiversity, geodiversity underpins human diversity. It's the bedrock of our national and cultural identity. The foundations of Mother Earth, our common home.
Good evening and welcome everyone, and indeed good afternoon to those joining us in Canada. Thank you so much for joining us today for this very special event, a celebration of the start of a new sistership partnership between the Discovery UNESCO Global Geopark in beautiful Newfoundland and Labrador, Canada, and the Charnwood Forest Geopark in Leicestershire in the UK. Tonight we've got some very special speakers who are going to talk a little bit more about why these two places are so amazing and why they have come together to work together to celebrate their geology and the way that geology and geodiversity affects all the things around us, our cultural heritage, our natural heritage, our communities and our society. We've also got two relatively young scientists who are going to be talking about some of their recent discoveries and share that with us, and the importance of discoveries being made in both areas and the product of those areas working together. And then last but not least, we're going to hear from Laura Davies, who is Ambassador and Permanent Delegate from the United Kingdom to UNESCO, who will be speaking not only from a UK perspective, but also on behalf of her colleague, the representative ambassador and permanent delegate from Canada. Thank you once more to all of you joining us from around the world. I can see we've got friends in not only from the two geoparks, but elsewhere around the world. I can see we've got Barry Langdon in from Bonavista. Good afternoon to you, Barry, and also a good evening to Kathy Shue, who's joining us from Woodhouse Eaves, and indeed everyone else joining us here today. I should say, particularly for our short scientific talks, if you do have any questions, do put them in the comments, which you're able to do for those people joining us live on Facebook and YouTube. If you pop your comment in the comments, your question, we will try and get through as many of those as possible in a joint question period at the end of those talks. But without further ado, I would like to introduce Edith Sampson, who is chair of the board at the Discovery UNESCO Global Geopark and has been part of the very long journey that region has gone on to secure the UNESCO status. She's been there all along, and we're very pleased to have her joining us this evening. Edith, how are you?
I'm fine, Jack. How are you?
Very good. Thank you very much. At this point, I shall retreat into the background and give you the floor. Thank you so much for joining us, Edith.
Thank you. Good evening, everyone. Ambassador Davies, members of both of the geoparks, friends from Canada, the UK, and around the world, welcome to the Discovery Global Geopark. We begin by respectfully acknowledging the territory in which I'm speaking from you today as the ancestral homelands of the Beothuk, whose culture has been lost forever and can never be recovered. We also acknowledge the island of Newfoundland as the ancestral homelands of the Beothuk and the Mi'kmaq, and we also recognize the Innu of Natassian, the Innu of Nunatsiavut, and the Innu of Nunatutvut as the original people of Labrador. As First Peoples have done since immemorial, we strive to be responsible stewards of the land and to respect the cultures, ceremonies, and traditions of all who call this place home. As we open our hearts and minds of the past, we commit ourselves to working in a spirit of truth and reconciliation to make for a better future for all. To our friends at Charnwood Forest, we're so pleased to be celebrating this new sistership between our two geoparks today. Discovery Geopark covers 280 kilometers of rugged coastline on the Bonavista Peninsula of Newfoundland and Labrador, and we are the easternmost province of Canada. Full of remarkable views of stunning cliffs, caves, sea arches, and sea stacks, our geopark hosts rocks that date back to nearly 600 million years. At 1,150 square kilometers, we're more than 7 times larger than Charnwood Forest, but with a population of 8,000 people, so we're spread across 27 communities. And in July of 2020, we became the UNESCO Global Geopark, which was the first for the province of Newfoundland and Labrador. Our stunning coastlines reveal stories of ancient rivers, shifting sea levels, and mysterious formations such as the Devil's footprints. We're also proud to host international significant fossils from the Ediacaran period. With more than 20 different species present, preserved in exceptional detail, we have become a hub of scientific research into the early animal life. And probably the most famous fossil is the Huhudia, a 560 million-year-old fossil that represents the first animal to flex its muscles. Of great importance to us, as it is for any geopark, is celebrating the links between our geology and our cultural heritage in our communities. For example, in Elliston, our geopark highlights the root cellars. People built to store produce over the winter. These structures are now a tourism attraction in their own right, and not only speaks to the local flagstone that they're built from and that defined their design, but also how geology has affected the settlement in the region. The thin soils that are left behind from ancient features control what we can and cannot grow in our area. And it has an impact on the traditional cuisine of the local area that includes normally root cellars, which are part of our normal lifestyle in our province. It is this geology that has closely to our new friends in Charnwood. 565 million years ago, when the fossils of our geoparks were still living on the deep sea floor, our regions were much closer together. It is only relatively speaking, with the opening of the Atlantic Ocean, that has really torn us apart. Even so, Charnwood Forest has had another impact on our region. The communities of our geopark are used to hearing about fossils such as Brigadia and Charnia, named after Leicestershire's Bradgate Park and Charnwood, and we look forward to celebrating the story of our common fossils through our sistership, and everything from joint work on geological interpretation to our educational programs. As we both reach out to our educational programming and local schools to tell the stories of the ancient continent of Avalonia, the fossils of Charnia and Fractofuchsias, and the amazing rise of animal life, there is much more we can develop together to engage young people with our geological history. Hopefully we can have an impact on the youth of the future to take on the roles of preservation and stewardship of these resources and our environments. There's also much work we can do together in the scientific research, a key theme to any geopark. As we will hear shortly from the two young researchers who will present tonight, There's great benefit to studying the fossils found in both of our geoparks, rather than just in one alone. It's also encouraging to see a new generation of scientists beginning their careers and choosing to do so on the rocks and fossils of our two great geoparks. We look very much looking forward to further collaborations with the long-standing research groups from Memorial University, Oxford and Cambridge universities, as well as new groups from around the world. We know there's still many great discoveries to be found, and we hope the sistership can prove that. And our sistership doesn't have to be rocks and fossils. We see this in a partnership, the potential for our towns and villages to work together, the opportunity to share the best practices for how we can care for and protect our natural heritage, to even bring businesses together and develop new products that can care for these lands and support our communities. Thank you once again to all that are here tonight, and particularly to the board of the Charnwood Forest Geopark. And we are all very excited for our new sistership. And I'm ending with a paraphrase of a Newfoundland saying, long may our big jib draw, meaning good fortune to you. And to end, I am pleased to introduce a brand new geotourism advertisement for the Discovery UNESCO Global Geopark, produced under the excellent leadership of our destination management organization, Legendary Coast of Eastern Newfoundland. And I'm sure in the video, you'll all recognize the narrator on the video. So thank you very much.
The Discovery UNESCO Global Geopark on the Bonavista Peninsula is a 280-kilometre-long celebration of how geology can shape our communities and culture. With so much to see and do, you can devote an entire trip to experience it all. The Rock. The Big Land. Newfoundland and Labrador is home to some of the greatest geological discoveries on the planet. Follow along as we journey across these legendary coasts, unearthing stories millions of years in the making. Among the 27 communities within the geopark, you can find remarkable geological stories that will take you back 500 million years. Like the tale of ancient rivers that form stunning multicoloured rock layers. Or a community of fossilised families that lived long ago. You can even uncover the legend of Hayutia, one of the first animals that ever flexed its muscles. This geopark has so many stories to tell. It's like a real-life choose-your-own adventure. No matter where you visit along this coast, the next chapter will always begin right beneath your feet.
Thank you so much once again, Edith there, the chair of the board at the Discovery UNESCO Global Geopark. Thank you for all your comments that are coming in so far. Lots of wonderfully positive words about what you were saying, Edith. Do keep those comments coming in via the Facebook comments and YouTube as well. Without further ado, we're going to travel across the Atlantic back to Charnwood Forest, where I'm going to introduce Councillor Richard Bailey, who is chair of the Charnwood Forest Regional Park Board, which is the organisation that oversees our geopark development project here. And I'm going to bring him into the stream right now. Councillor Bailey, how are you?
Very well, thank you, Jack. How are you?
Wonderful, wonderful. Thank you for joining us here tonight, live all around the world. And without further ado, please do take it away.
Thank you very much, Jack. Ambassador Davies, members of the boards of both geoparks, friends and guests from around the world, welcome to Charnwood Forest. I'm speaking to you this evening from my home deep in the middle of the Charnwood Forest, which is an amazing place to be, and I'm great privilege to live and work both within the Charnwood Forest itself. Can I begin by thanking Edith for her remarks as we begin our journey as a geopark? We are excited to be doing so hand in hand with our new Canadian friends who have already overcome so many of the challenges and seized the opportunities that lie ahead for a UNESCO Global Park. Charnwood Forest is Britain's unexpected upland. Having begun its journey nearly 600 million years ago in the seas of the Southern Hemisphere, it's a very special region indeed, and has continued to develop rich layers of heritage. We are home to some of the oldest animal fossils ever described and have quarries whose stone has shaped not only our amazing villages around the area, but also many English cities as well. Our landscape is defined by crag-top hills, wooded valleys, heathlands and grasslands. Shady lanes revealed arts and craft cottages, ancient monasteries and dry stone walls. And for those of you who know the area well, you'll be getting a sense of how it all shapes together. However, our region's value and beauty are hidden from many communities, despite being on the doorstep of cities, towns and villages. Charnwood Forest is at risk. If people are not passionate about our region, they will not understand its importance. Ultimately, the features that make it very special risk being forgotten and lost. This is where our Geopark project comes in. The story of Charnwood Forest needs to be told. We are now beginning to celebrate our internationally important geology, connecting people in our history and securing a sustainable future. That's why we are creating Charnwood Forest Geopark. At this point, I want to mention our thanks to the National Lottery Heritage Fund, who through the Charnwood Forest Landscape Partnership Scheme are funding a 5-year project to promote awareness and understanding of the Charnwood Forest through 18 funded projects. Edith has already mentioned our shared geological history between Discovery and Charnwood Forest, and we are so proud to be home of the first fossils discovered that changed our understanding of evolution. Our shared geological history also stretches to more recent times. It's worthy of note that James B.T. Jukes, who produced the first geological survey of the island of Newfoundland in 1842, also made one of the very first geological maps of Charnwood Forest in 1836. But it's not just the rocks beneath our feet that link our regions together. I am told that we share some vocabulary throughout the two regions as well, and apparently that on visiting a coffee shop or restaurant on the Buena Vista Peninsula, you might be referred to as Miduki. For those of our Canadian friends that are tuning in, and for those that are around the world, you might get a similar greeting while buying a cup of tea in the cafe at Beacon Hill or ordering a pint in one of our fine country pubs. So we do share quite a bit more than just the geological history. As we look to the future, our sistership offers new opportunities for collaboration in areas such as geological interpretation and public engagement. With rocks of a similar age containing in some instances exactly the same species or fossils, which is amazing considering as we now look at the geographical divide between us, there is much we can work together to better tell the amazing story and the rise of animal life. We are also looking forward to work we can do together on sustainable geotourism, and that we can support our businesses and local communities while also enhancing the conservation of amazing natural heritage found at both geoparks. Thank you once more to everyone for joining us here today, and for anyone watching from Charnwood Forest, if you're interested to know more about the Geopark or the opportunities of the sistership with Discovery, please do get in touch. Finally, to give you a quick sense of what amazing region this is like, we now will play a short video produced recently to promote the Charnwood Forest and the wider Charnwood region. Thank you.
It's time to discover Charnwood. Perfectly located right in the center of the country and enjoying superb transport links, there is no better place to visit, work and live. For nearly 600 million years, the powerful forces of nature have been sculpting our breathtaking landscapes. Evidence of our unique geological history is scattered among picturesque villages and can be experienced up close in the rocks of Bradgate Park and Beacon Hill. Such is the importance of Charnwood Forest, it is now an aspiring UNESCO Global Geopark. At the heart of this dramatic landscape is the dynamic university and market town of Loughborough, home to the last major bell foundry in the UK, 800-year-old markets and the Great Central Heritage Railway. In Charnwood, we are proud of our past and excited for our future. Our award-winning Loughborough University and cutting-edge science and enterprise parks are leading world-class research, innovation and sport, and nurturing the stars and heroes of future generations. Discover Charnwood, a fascinating destination promising a non-stop voyage from ancient origins to future potential. In Charnwood, we are shaping tomorrow's world today.
Thank you again to Councillor Richard Bailey for those very warm words to start off our partnership between the two geoparks. Next up is the first of our scientist speakers. And just a reminder to everyone who's joining us live all around the world, if you do have any questions for our two scientists today, after they've both spoken, we'll have a little bit of time to put as many of your questions as we can. So if you're joining us on YouTube or on Facebook, you can put your questions in the comments and we'll try and put as many of those to our scientists as possible. Both of them are going to talk on topics around paleontology, the study of fossils, and they're going to talk from the point of view of some studies that they have done that reflect on fossils found in more than one country, importantly, the UK and in Canada. The first of those is Daniel Perez-Pinedo, or Danny as he's known to his colleagues. I'm going to bring you into the stream now. How are you, Danny?
Good, how are you, Jack? How are you doing? Hi, everyone.
Good. Thank you for joining us today from Memorial University of Newfoundland and Labrador, where Danny is a PhD candidate in the paleobiology research group there, which has a very long history of working both on the ancient fossils of eastern Newfoundland, but also on the fossils that are found here in the Charnwood Forest Geopark. With that, I'm not going to spoil the wonderful treasures you're going to share with us today, Danny. So I'll pop your slides up on the screen and I'll disappear. Take it away, Danny.
Thank you, Jack. Well, hi, everyone. As Jack said, my name is Daniel Perez-Pinedo, and I am a PhD candidate at Memorial University of Newfoundland. And well, first of all, thank you, everyone, for attending this event. And I'm going to be introducing my talk, Charnodiscus, a bridge over the Atlantic. Charnodiscus is the fossil that I'll be talking about. It's going to be very straightforward, so yeah, no panic. I called it a bridge over the Atlantic because it's an excellent example of a species that can be found both in Charnwood Forest Geopark and in several locations in Newfoundland, in Canada. So first, a short introduction of what is Charnodiscus. Charnodiscus is one of the most iconic Ediacaran fossils. Therefore, it's older than 500 million years. And Charnodiscus concentricus is the type species of the genus, meaning that is the species that characterizes all the other species grouped within the same genus. It was originally described in 1958 from Charnwood Forest. And in the original description, Charnodiscus concentricus was described as the disc of a charnia. If you can see, which is a different species. The two panels in the middle, you can see that they're divided in two. The upper panel is the upper frondose section of Acharnia, it's a different species, and the bottom panel, where you can see that basal disc or holdfast, is the basal part of Acharnodiscus concentricus. In the original descriptions in 1958, they were kind of put together. They were thought to be the same specimen, and you can see that reconstruction on the left-hand side, where you can see the frondose section of Acharnia, which I believe Frankie will talk about later, attached to the holdfast or basal disc of Acharnodiscus concentricus. It was not until 1962, 1963, when Charnwoodiscus concentricus was described as its own species, not part of Acharnia. And you can see that on the right-hand side. That panel is what we see in the fossil record. You can see the holdfast and the stem at the bottom attached to the original frond that you can see above the tiny crack that you see on the panel on the right-hand side. And well, after ongoing paleontological debate, Charnwoodiscus concentricus, or at least modern paleontology, has interpreted Charnwoodiscus concentricus as an organism consisting of 3 sheets or veins or sections, or whatever you want to call it, of branches. You can see these sections colored in blue, green, and red on the right-hand side of the image. And this organism has been interpreted to have lived upright, erect into the water column, as you can see in the picture on the left-hand side, those purple, funny-looking creatures. And well, I'm going to talk about what we did in our research. We basically came up with a new taphonomic and paleobiological interpretation of the type species Charnwoodiscus concentricus from Charnwood Forest. We basically started the preservation of different parts of the fossil. You can see on the panel all the way to the left, you can see different branches colored differently. So we studied the different folding patterns of the branches. We also studied the preservation of the stem and the holdfast. We studied how features are preserved. Some of them can be preserved in negative reliefs, and some of them can be preserved in positive reliefs. And we also studied the different preservation planes. Some features, some branches are preserved at low planes, and some other features are preserved at higher planes, three-dimensionally speaking, because of sediments being trapped in between planes. So putting everything together, we came up with an integral approach, and we reconstructed Charnwoodiscus concentricus as what you can see inside that red rectangle in the image on the right-hand side. We reconstructed it as a conical frond consisting of 2 sheets of branches, not 3. And what you can see on the right-hand side is basically a stop motion model, a whole reconstruction of what happened to the branches. It's a whole sequence of different branch folding from A to I, and I is what we see in the fossil record. So basically what we did is, from what we see in the fossil record, we traveled back in time and we reconstructed how the organism actually looked before it was preserved as a fossil. This new paleobiological reconstruction of Charnwoodiscus as a conical and a bifoliate frond, meaning 2 sheets of branches, was also supported by additional fossil evidence gathered from different locations in Newfoundland in Canada. For example, you can see in the image number 1, it's from Upper Island Cove. It's a fossil assemblage called the Spaniards Bay assemblage. And what we can see in fossil number 1 is basically a cross-sectional view of Charnwoodiscus. We can see the internal mold of the conical structure. And the other 2 pictures labeled with number 2 from the very famous Mistaken Point Ecological Reserve are different specimens of Charnwoodiscus showing very similar branching folding and branching patterns, similar as to the ones we observed in Charnwood. And having reconstructed, came up with a new interpretation for Charnwoodiscus concentricus, that has implications for its sister species, so to say. So now we have some Charnwoodiscus specimens from especially Discovery Global Geopark that show very similar preservation as the specimen from Charnwood Forest. And it's some others show very different features, and that's the goal for future research. The ones that show very different features will probably need to be classified as something else, But the importance is that having studied the specimen from Charnwood Forest gave us the tools, gave us the understanding, gave us the skills to now study and understand the specimens from Global Discovery Geopark in the Bonavista Peninsula of Newfoundland. And well, I think that's it. Yeah, that's it. And well, just thanks to Discovery Global Geopark for letting us work with their fantastic material and their super scenic fossiliferous surfaces. Thank you very much to Charnwood Forest as well for having let us work with their super iconic Ediacaran fossils, and also to my colleagues from MUN Paleobiology Research Group. And well, this whole story that I talked to you about is described in detail in a paper that was recently published in January in Frontiers in Net Science. So you have the link there. If not, you can always Google the name of the paper and you can read it online. And well, that's it. Thank you very much.
Thank you so much, Danny. And as he's just said there, if that's whet your appetite for a little bit more Ediacaran paleontology, you want to know more about these beasties from nearly 565, some even a little bit older than that, some 574 million years ago. There is his paper with his team there. Do look that up to find out more. A reminder, if you've got any questions after Danny's talk, do pop them in the comments. We'll put them to our scientific speakers together at the end. But at this point, I'm going to invite Dr. Frankie Dunn onto the screen. Thank you once more, Danny. And we'll go over to Dr. Frankie Dunn, who is an 1851 early career research fellow at the Oxford University Museum of Natural History, where she joined the museum having done a PhD at the University of Bristol, and is now a passionate advocate for Ediacaran paleontology, and has been coming up with some wonderful discoveries, one of which I think we're going to hear about today. Frankie, how are you?
Very well, thank you. Thank you for having me.
Excellent. Are your slides ready to pop onto the screen?
Yeah, I'll just swipe over as soon as that starts.
Excellent. I will pop that on. I think we'll have a bit where it goes. Oh, there we go. It's appropriate that the screen went rather fractal there when we're discussing Ediacaran paleontology. Take it away, Frankie.
Thank you. So once again, thank you very much for having me today. So I thought I'd just start by talking very briefly about my research interests. So I'm a paleobiologist, and I'm interested principally in understanding the generation of animal form. Animals today are a hyper-diverse group with radically divergent body plans, some of which, and only some of which, you can see on the slide in front of you. And I'm interested in understanding the origin of this rich biodiversity. And so as a paleontologist who wants to understand these questions, I'm also trained in comparative anatomy, as are many other paleontologists, because this is the tool that allows us to rationalize the anatomy of extinct beasties against their living counterparts. So you can see on the left of my slide, from much younger rocks, is an animal called Coolosuchus. This lived at the time of the dinosaurs, and it displays remarkable anatomical similarity to living amphibians like salamanders, with those handsome racing stripes also on my slide. And so we know that Coolosuchus is, in fact, an ancient amphibian. And we can take this strategy, what does this look like? What is it? Back perhaps a surprisingly long way. So this is a fossil called Waptia, and it lived in the oceans about 505 million years ago. And you might think that it looks a bit like a shrimp. And in fact, we know that it is actually, it belongs to the same group as shrimps. It's related to crustaceans. And so we can say something, I think, quite fundamental, and that's that animal body plans have been fixed. We can recognize them for more than 500 million years. So if you went snorkeling just over 500 million years ago when Waptia was alive, you'd probably be able to recognize quite a lot of the animals that you'd find swimming with you. But we don't need to go back very much further into the preceding geological period, the Ediacaran period, to find things with totally extinct body plans. And these are what I work on. So this is a partial specimen of Charnia, which Danny just introduced you to. And Charnia is part of a group of fronds called the Rangiomorphs, which are made up of serially repeated branches, which I think you can see on this specimen on my slide. And we find it more or less coevally with other strange organisms like these guys. I think they look a bit like thumbprints. They're called the Dickinsoniomorphs. And we unite Rangiomorphs like Charnia, the Dickinsoniomorphs, and other strange beasties into a group called the Ediacaran macrobiota for the time they lived, the Ediacaran period, but also because together they display these non-analog extinct body plans. And I'm sure it won't be a galloping shock to hear that fossils of the Ediacaran macrobiota have remained kind of stubbornly enigmatic since their first discovery. But it's very, very tempting to imagine that these guys might represent the oldest animals that the fossil record yet gives up. And that's why I got into studying them. So I've been working principally on Charnia, which is found in both Discovery and Charnwood. And my approach to understanding what these things are is to try and understand how they were growing. Because growth characters are actually tightly conserved across huge swathes of geological time. So I'm going to introduce you to two jargon terms now, and only two, I promise. So when we talk about how a rangiomorph like Charnia is constructed, we divide the branches into first order branches shown in green, and we say first order branches are made up of second order branches shown in yellow. And it's those second order branches I'm about to talk about. So some specimens of Charnia are preserved in 3 dimensions, which means that we can see inside them if we subject them to CT scanning, just like you do if a doctor needs to look inside your body. And what you can see on the left-hand side of my screen is the result. It's a CT scan of Charnia. And I've highlighted in all those different colors individual second order branches. And the only thing I want you to take away from this is that the entire width of the frond is made up of second order branches. There is no room from a stalk. And this means that branches must derive directly from one another. So first order branches derive directly from one another, and a given first order branch is entirely constructed of a second order branch. And this is an anatomical arrangement that we call sympodial growth. And with this in mind, understanding how growth proceeds across one specimen, I was able then to consider growth across populations of Charnias. And I picked one specific population from Charnwood Forest. And what we found is that we were able to produce a developmental model. So we rationalized developmental pattern in a fossil that's more than 570 million years old. And some of the key things that we noted was that Charnia adds new branches over time from an apical generative zone, so at the top of the frond, and that the position of the longest branches, shown in my little drawings in green, shifts basally as the frond age. And this might be to do with conferring stability in the water column. And also that there's a shift in the relative importance of 2 growth modes across the known life cycle of Charnia. So in this case, early in the life cycle, Charnia adds a lot of branches, and later in the life cycle, Charnia just inflates the branches that it has. And together, these characters are only found in living animals. And so we can say that Charnia and its near kin, the other rangiomorphs, are animals. But we can do better than that. We can subject Charnia to other kinds of analyses to try and work out where it sits in the animal tree of life. And that's what we did. And you really don't need to worry about any of the details of this slide. The only message I want to convey is that whatever we did, we found that Charnia, and so presumably other rangiomorphs, but I'll more on that in a second, were ancestors to all animals with body tissues. And you might be thinking, surely all animals have body tissues, but that's not the case. The oldest, the most ancient animals are sponges, like those you find in your bath and also in the deep sea. And they don't have body tissues at all. But interestingly, they also don't display a very regulated pattern of growth. So we've got no evidence that Charnia has body tissues like muscles or nerves, but we know that it does have a very highly regulated pattern of growth. Now, the rest of animal diversity, all animals with body tissues, which together we call the eumetazoa, they have both a regulated pattern of growth and also things like muscles and nerves. And so it seems like this highly regulated pattern of growth was necessary to develop this organ grade complexity. And so we can see the stepwise acquisition of parts of anatomy, which have allowed animals to diversify and colonize pretty much all environments on Earth today. So this is all really cool, but Charnia is just one rangiomorph, and rangiomorphs have evolved many different branching shapes. So in order to be sure of what we're saying, we need to test our hypothesis in another rangiomorph, which is what I've been doing. So I've been working on another rangiomorph called Fractophusis. So this is a fossil that we actually only find in parts of Newfoundland, including the Discovery Geopark, and it's about as different from Charnia as you can imagine. So Charnia had a holdfast disc and was upright in the water column. Fractophusis, like you can see from my schematic, and also the fossil on the right-hand side there, was a spindle-shaped organism which laid flat on the seafloor. And I won't bore you by talking you through the graphs I put on the left, but I just want to say that actually what we find is that Fractophusis shows a very similar pattern of growth to Charnia. Rangiomorph growth is variation on a common theme, and this provides confidence in our model of growth and also where we've put rangiomorphs in the tree of life. And this is only possible by studying fossils from both of the geoparks. So I'll just finish with the broader implications of this work, which I think helped to address one of the longest standing mysteries in paleobiology, Darwin's dilemma, the profound imperfection of the geological record. So when Charles Darwin wrote his theory on the origin of species, he said that innumerable transitional forms must have existed, which fill the gap between different animal groups today, where we have discrete anatomies like a fish and an earthworm look nothing alike. But we don't find them embedded in countless numbers in crusts of the earth. And why is this? This was the biggest problem as Darwin saw it to his theory. And the answer is that we do find them. Charnia and other rangiomorphs are these transitional forms. It's just really, really difficult to identify ancestors to major animal groups. And so we need to turn to techniques like the study of growth and development to be able to understand the fossil record. But Charnia and its near-kin other rangiomorphs possess anatomies that could not be predicted by examination of exclusively living animals. And so this validates what paleontologists do, I think. We need to turn to the fossil record to be able to actually understand the earliest steps in animal evolution. And so I'll leave it there. Thank you so much for listening. And I'll just highlight my funders and institutions. Yeah, thank you very much.
Thank you so much to Frankie for that wonderful tour of some of your recent work on not only Charnia, but we got a tantalizing glimpse into your soon-to-be published work on the wonderful Fractophusis, only found from the beautiful shores of the island of Newfoundland. Right, at that point, I'm going to invite Danny back onto the screen, and we're going to see if we have any questions. Just a reminder, if you do have any questions for Frankie or Danny, do pop them in the comments, either on Facebook or on YouTube. We've got a few moments to do those. I'm just going to start by putting up some comments. We've got a comment from Julie Attard, who joins us today from Leicester. Julie is the project manager of the Charnwood Forest Landscape Partnership Scheme project. And thanks, Danny, for a fantastic talk and all the work you're doing on research and new discoveries. And we're also seeing, Atul is in the room as well. Amazing talks from both the Atul there, the independent chair of the Charnwood Forest Landscape Partnership Scheme. Right, we have a question. I'm going to put this to Frankie first, because I think it can go to both of you. And it's often a question that paleontologists get asked, if it is particularly those working in what we call deep time. And it's from Anne Irving, and it is this: how does knowing all of this help us today? Frankie?
Well, I think there are three principal answers to this. The first is cultural. I think we all want to know intrinsically where we've come from. And so understanding our early fossil record is really important. I think it fills some need within us. But there are two more scientific reasons. The first is that actually we use the early evolution of animals to understand the evolutionary process. It's a proxy for understanding this. And until we understand early animal evolution, and particularly integrate Ediacaran fossils, which typically haven't been done, our understanding of early animal evolution, and therefore the evolutionary process, will be incomplete. And there are a number of studies which demonstrate this, where they have proposed hypotheses which have been falsified by incorporating data from the Ediacaran period or elsewhere. The other is more specific to my work, so I'm really interested in understanding the evolution of developmental pattern, so how organisms change from embryo to adult. And it's we can observe things going wrong in Rangiomorphs and closely related things from the Ediacaran period. And it's these same developmental patterns which we can observe working and going wrong in the Ediacaran period, which are fixed over more than 500 million years and go wrong today in animals that we find alive today. And so understanding the context in which these what we would call gene regulatory networks, so how development is encoded at the genetic level, all these millions and millions and millions of years ago, can tell us something about how animals grow and develop in the living world today. So that's my answer.
Wonderful. Thank you, Frankie. And just a reminder that Ediacaran is a good word to remember for today. It's the age of the rocks which are of such significance both in Discovery and in Charnwood Forest, and it runs from 635 to 540 million years ago. So Ediacaran is your word of the day, to go along with such brilliant phrases in Frankie's talk as sympodial growth. But I do like the phrase galloping shock too. Weave those into your conversations over the next week. Danny, any further thoughts on that question? Why does knowing this, why does investigating ancient beasties from 565 million years ago, why should we care about it today?
Yeah, I think from a biological perspective, as Frankie mentioned, all the evolutionary innovations and evolutionary patterns that act in the natural world, just building knowledge of like where we come from, how early evolution took place in the origin of these creatures. I think it's just how it is useful. I think it's a rather philosophical question, I'd say, and it's just generating knowledge that like in my opinion that goal is good enough for me, for sure. But it is a complex question, and I'd say it's a philosophical question. It has many different answers, but from a scientific point of view, I'd say it's critical to understand in the understanding of early animal evolution, evolutionary patterns, and innovations.
I think I totally agree with what Frankie and Danny are saying. I would simply add that as they continue to do their brilliant work, to reveal new and interesting stories about fossils and rocks from both geoparks, I must say, from the point of view of people like myself, it then makes it easier to get people to understand why we need to look after these, why we need to conserve and protect them. So the more that Frankie and Danny do, the easier it is to get people to understand why the conservation of geology is just as important as the conservation of biology. And at that point, we've got a few moments left. So I'm just going to a quick fire question to both of you. And we'll start with Danny this time. What is the benefit to studying these ancient rocks from both regions? Are there things that you see in one place that you don't see in the other? Are there different features? Why is it so interesting and useful to study two places now thousands of miles apart?
Well, for example, in my case with Charnwood Discus, the fact that we got to study the type material from Charnwood Forest, understanding the preservation of Charnwood Discus concentricus had important implications in the taxonomy of the genus as a whole. So it had implications in the classification of other species that were also found in this case in Bonavista Peninsula, for example. So understanding, in my case, the preservation of these features in the type species of Charnwood Forest now is going to give me, or us, our team, the skills, the understanding to understand what's happening to all the specimens in the Avalon Peninsula or in the Bonavista Peninsula. As I said, there are some species in the Bonavista Peninsula in Discovery Global Geopark that were described, well, some specimens that were reported in 2008, that we believe they show very, very similar preservation to the specimen in Charnwood Forest. And so far, they've been described as probably different creatures. Some of them are very similar to the specimen from Charnwood Discus, so I think they might have to be classified in different categories, taxonomically speaking. But yeah, I think that's just kind of like importing those or exporting those skills that we gain from one site and the other.
Thank you, Danny. Frankie, any thoughts on that question?
Yeah, well, so I agree with Danny. It's really important to study fossils from different sites because they're preserved in different ways, and that can give us new anatomical characters with which to reconstruct how they looked or how they behaved, but also because these sites record subtly different environmental regimes, and this has led to totally different community structures. And this is really interesting for lots of different reasons, I think. So, for example, fractifusis, we find this in Discovery. We don't find it at all in Charnwood. Why is that? So we can understand these kinds of ecological questions. And there's a group of people working on this at the minute. So Emily Mitchell and Charlotte Kenchington at Cambridge are both looking at this kind of stuff. We can also look at things like intraspecific variation. So like microevolutionary change almost. These are the nature of the preservation of these fossils in these huge communities. It's basically like a natural evolutionary experiment, and incorporating data from as many sites as is possible, not just Discovery and Charnwood, which are obviously extremely complementary, but the rest of the sites in Newfoundland and around the world allow us to test hypotheses which are simply not available to us in the rest of the fossil record. So yeah, that's what I would say. It's a natural evolutionary experiment.
It sounds like, Frankie, you're paraphrasing an ancient president of the Geological Society of London in saying, the paleontologist who sees the most fossils wins.
Yes.
Excellent, excellent. Thank you so much once more to Danny and Frankie for joining us this evening. I'm sure we will be seeing more of them and their work and the teams that they work with in the coming months and years. I'm sure they have new discoveries that they'll want to share with us. And hopefully one of the things we can do to work together is have more events like this online, sharing the amazing discoveries that still continue to be found, both in Newfoundland and Labrador and here in Leicestershire in the UK. Thanks once more to Frankie and Danny. Now, our last speaker of the evening is Laura Davies, who is the Ambassador and Permanent Delegate from the United Kingdom to UNESCO. UNESCO is the education, scientific and cultural organisation of the UN, and it is the only branch of the United Nations which has a responsibility for the geological sciences. And that's why the Geopark movement and indeed the International Geoscience Programme, amongst other things, are under the umbrella of UNESCO. We're very, very pleased to have Laura joining us live here today. Laura, how are you? I think you... Oh, there we go. How are you?
Very well, thank you. Much wiser about paleobiology than I was a few minutes ago.
Excellent, excellent. Yes, I think you only need a few moments with people like Frankie and Danny to get a snapshot into this miraculous ancient world. At that point, I will zoom into the background, and please do take the floor. Thank you so much for joining us.
Thank you, Jack, and thank you to Frankie and Danny. You both have the gift of giving people the impression for a few minutes that they too understand the paleobiology that you've been describing for us. It was a really fascinating couple of lectures. I am absolutely delighted to be here this evening, or this afternoon, for those in Canada, to congratulate Discovery Global Geopark in Newfoundland and Labrador and Charnwood Forest Aspiring Global Geopark on this new sistership, and to do so not just on behalf of the UK, but also of Canada. My good friend and colleague, Her Excellency Natasha Cayer of Canada, is really sorry not to be able to join us this evening, but I have to admit that we're both slightly tickled to be able to demonstrate through this joint address that we have our own sistership here at UNESCO. The Canada-UK collaboration on UNESCO projects is thriving, despite the very best efforts of the Atlantic Ocean. From site coordinators to national governments, from communities to national commissions, we all enjoy strong and supportive relationships. So it's only natural that our geoparks should enjoy the same links. All the more so, given the inspiring geology that Discovery-Charnwood Forest share, ancient rocks that mark the explosion of life forms, the biological Big Bang that Frankie and Danny have just taken us through. But we are now firmly in the Anthropocene era, a time when human activity is having a significant impact on the climate and on ecosystems. And that's why we really need the geoparks to understand our past and at the same time to commit to a more sustainable future. Because being a global geopark doesn't just mean having great rocks, it's about harnessing that extraordinary geology to teach communities and visitors about our past and our future. And both Discovery Geopark and Charnwood Forest Geopark are doing this by the bucket load. So no wonder that you've stirred the imagination of scientists and the general public alike. I know that this sistership will enable the sites and the communities within them to promote, celebrate, and share best practices, including educational materials and geotourism. You'll be sharing your geo-heritage, exchanging art, music, cuisine, history, and built heritage, and run shared events underpinned by your amazing geological environments. And that's exactly what UNESCO is all about, building mutual understanding, dialogue, and peace between the peoples of the world. The father of modern geology, James Hutton, said, "It's the little causes, long continued, which are considered as bringing about the greatest changes of the earth." I hope this new sistership will be long and fruitful, an inspiration for other geoparks around the world, and its own little cause, long continued, that contributes to making life on our planet sustainable for future generations. Thank you all very much, and congratulations once again.
Thank you so much for those words, Ambassador Davies. I think we had a few connection problems, but the audio was coming through. So thank you so much for those very kind words. We're very excited to be starting this new across the Atlantic, transatlantic relationship. And thank you also, it should be said, to Natasha Cayer, her Excellency Ambassador and Permanent Delegate of Canada to UNESCO, who Laura is speaking on behalf of today as well. We're really grateful to the support of both of the permanent delegation teams. And it should also be said, the national commissions in both countries who've been incredibly supportive of what we're doing. Thank you so much to them. With that, we are done and we are just about on time. I'm glad to say, hopefully this beckons for productive, timely relationships in the future for our sistership work. Thank you to everyone who has joined us from all around the world, not only the UK and Canada. We very much hope to be joining you again live with events from Charnwood Forest and the Discovery UNESCO Global Geopark. And thank you once more to all of our speakers tonight for your thoughts about what the future holds, and also some very interesting geological discoveries. We wish you peace and good safety, and we very much look forward to seeing you soon. Thank you once more, and good afternoon or good evening.